Ever look up at the night sky and just, I don't know, feel like what we can see is just this tiny little window into something much, much bigger?
I know what you mean.
Like, what if our universe isn't the whole shebang, just one of countless others out there?
Parallel universes.
Exactly. It sounds like something straight out of science fiction.
Right.
But today, we're taking a deep dive into that very idea, parallel universes, using physicist Max Tegmark's paper, appropriately titled Parallel Universes. Ready to have your mind blown?
I'm ready. Let's do it.
Okay, so before we dive into the really weird stuff, I gotta ask, when scientists talk about parallel universes, what exactly are they talking about?
Well, you might be surprised to learn that there isn't just one type of parallel universe that they consider. Tegmark actually breaks them down into 4 distinct levels, each one building on the last.
4 levels of parallel universes. Okay, you're going to break that down for me. Starting with, let's see, level I. What's the deal with level I parallel universes?
So level I is probably the easiest to wrap your head around. Imagine, if you will, space just stretching out, going on forever. Infinite space.
Infinite space. Okay,
Mhm.
I can kind of picture that, at least in theory. But is it just like empty space forever?
Not quite. Tegmark argues that based on what we know, things like the cosmic microwave background radiation and how matter is distributed space isn't just likely infinite, but it also means that there are potentially infinite regions out there that are similar to our observable universe.
So like a bunch of mini universes scattered throughout this vast infinite expanse.
Exactly. And here's where it gets really interesting, because there are potentially infinite of these regions, and they all formed with slightly different distributions of matter and energy. Statistically speaking, everything that's possible has happened somewhere.
Whoa, wait a minute. So you're saying there's another me out there somewhere living a different life because the initial conditions of their universe were a little different from ours?
That's the implication, yeah. Another you, making different choices, maybe even with a slightly different set of physics governing their world.
Okay, now my mind is starting to bend a little.
Yeah.
But how can we be sure? If these other universes are so far away that light hasn't had time to reach us, how could we ever know if they even exist?
You're right, we can't observe them directly. However, their existence isn't just wild speculation, it's an extrapolation of what we do know about the universe's structure and the laws of physics that govern it. Just like we haven't traveled to distant stars, but we know they exist based on our understanding of astrophysics.
So, to use an analogy, it's kind of like we've explored enough of Earth to have a general idea of what the rest of it looks like, even if we haven't visited every single spot.
Precisely. Just like we use our understanding of physics to predict things like black holes, which we can't see directly, we can use those same principles to infer the existence of these other universes beyond our cosmic horizon.
Okay, I think I'm starting to wrap my head around level infinite space, infinite possibilities, infinite versions of me out there somewhere. But what about level 2? Where do we go from here?
Level 2 takes this concept of infinity and adds, shall we say, another layer of complexity.
Oh boy. Okay, hit me with it. What's level 2 all about?
Well, hold on to your hats, because level 2 involves something called chaotic inflation.
Chaotic inflation. I'm intrigued, but you're going to have to walk me through that one.
Okay, so picture this. Right after the Big Bang, the universe went through a period of super-duper rapid expansion, right? That's inflation.
Right, got it.
Well, chaotic inflation basically says that this inflation, it didn't stop everywhere at the same time.
Interesting. So some parts of the universe are still inflating today. What happens to those areas?
Here's where it gets wild. These inflating regions, they can actually bud off, creating new bubble universes, each of them potentially with its own unique set of physical laws.
Hold on. New universes with different laws of physics, like different rules governing how things work. Okay, now you're just messing with me.
I wouldn't dream of it. But think about it.
I mean, that's a lot to process.
Imagine a universe where gravity works differently, or where there are 11 dimensions instead of our familiar 4.
Okay, different dimensions, different laws of physics. My imagination is working overtime right now, but help me connect the dots here. How does this budding off actually happen?
Okay, so think of it like this. You know how when you boil water, you get those bubbles that rise up and break away from the rest of the water?
Yeah, I see where you're going with this.
It's kind of like that. The early universe, it was so chaotic and energetic that it caused these regions of space to rapidly expand and essentially pinch off from each other, kind of like those boiling water bubbles. And each of those bubbles, well, they became their own separate universes, each with the potential for its own unique set of physical laws.
So you're saying the speed of light could be different in these other universes, or gravity could be stronger or weaker?
Exactly. The fundamental forces of nature, the things that govern how everything interacts, they might behave in ways that, honestly, we can't even begin to imagine.
Okay, wow. That's a lot to take in.
It is. It is. And it leads to some really intriguing questions. For example, this whole idea of fine-tuning, remember that?
Fine-tuning. Yeah, it rings a bell, but maybe you can refresh my memory.
Sure. So the fine-tuning argument basically points out that the physical constants in our universe, like the strength of gravity or the speed of light, they seem incredibly fine-tuned for life to exist. Like
Well,
the universe hit the cosmic jackpot or something, even tiny variations in these constants, and it's possible none of us would be here.
I see what you mean. So it's like the universe we live in just happened to get incredibly lucky with the perfect combination for stars to form, planets to exist, and for life to arise.
That's one way to look at it. But the level 2 multiverse, it offers another possible explanation. Maybe our universe, with its seemingly fine-tuned parameters, it's not so special after all. Maybe it's just one of countless universes in this much, much larger multiverse, each with its own set of physical laws and constants.
So instead of one incredibly lucky roll of the cosmic dice, we're talking about infinite dice being rolled, each with a different combination, and we just happen to be in the universe where the dice landed in favor of, well, us.
Precisely. Most universes, they might be total duds, totally unable to support life as we know it. But when you're dealing with infinite possibilities, well, some of those universes are bound to get the winning combination.
I mean, I gotta ask,
Uh-huh.
if there are infinite universes with infinite possibilities, does that mean somewhere out there, there's a universe where I'm like a rock star?
That's a question that level 3 might be able to shed some light on.
Level 3, okay, bring it on. What new form of weirdness does level 3 have in store for us?
Well, level 3, it dives headfirst into the world of quantum mechanics and the many worlds interpretation, which basically says every time a quantum measurement is made, the universe splits. And each possible outcome of that measurement, it plays out in its own separate universe.
Wait, hold on. Are you saying it's like a choose-your-own-adventure book, but instead of you picking one path, every path happens, each in its own universe?
That's a great way to think about it, yeah. Every quantum event, every interaction between those tiny particles, it creates a branching point in reality, a fork in the cosmic road, if you will.
So are you saying there are countless versions of me out there, each one experiencing a different outcome of every single quantum event in my life? Like in one universe, I eat cereal for breakfast, but in another, I had pancakes.
You got it. That's the essence of the many worlds interpretation. But here's where Tegmark, he adds an interesting twist. He argues that all this branching, it doesn't actually create new universes, at least not beyond what's already out there in levels 1 and 2.
Okay, now I'm a little lost. How can you have infinite branching without infinite universes? My brain's starting to hurt.
I hear you. It's a tough one to wrap your head around. Think of it this way. The possibilities, they're already baked into the system. Level I gives us the infinite universe with all the possible initial configurations, right? Level 2, it adds on top of that with the potential for different laws of physics in different universes. And level 3 is basically saying that within all those already existing possibilities, every single quantum outcome, it's already happening. It's not adding new pages to the book, it's just realizing that all the pages were always there, just on different branches of reality.
So level 3 is less about creating new universes and more about saying that every possibility within the multiverse that levels I and 2 already provide, those possibilities are being realized somewhere.
Exactly. It takes the concept of infinite possibilities and applies it to the quantum realm, suggesting that every outcome of every quantum event is playing out in some corner of this vast multiverse.
Okay, I think I'm starting to get a handle on the mind-blowing scope of level 3. We've gone from an infinite universe with infinite versions of ourselves to an infinite multiverse with infinite sets of physical laws, and now to a reality where every quantum possibility branches off into its own separate timeline. What could possibly be more mind-boggling than that?
Oh, you'd be surprised. Tegmark saves the most abstract and perhaps most profound for last. Get ready, because we're about to climb the final rung of the multiverse ladder, level 5.
Level 4, okay, lay it on me. After everything we've talked about, I'm almost afraid to see what ultimate reality has in store.
Yeah.
Level 4, right? After infinite universes and branching timelines, where do we even go from there?
Well, let's just say level 4 takes us on a bit of a trip into the realm where physics meets philosophy.
Ooh, okay. I'm intrigued.
Tegmark calls it the mathematical universe hypothesis.
Okay, catchy name. What's the mathematical universe hypothesis all about?
In a nutshell, it proposes that mathematical structures aren't just something we humans invented, but that they're actually the fundamental reality of our universe.
Wait, so you're saying that math isn't just a way to describe the universe, math is the universe?
Exactly. Think about it. We use math to describe pretty much everything in physics, right? The motion of planets, the behavior of subatomic particles. Tegmark's saying those mathematical relationships aren't just descriptions, they are the universe.
So instead of thinking of the universe as this big physical thing, we should think of it as one massive equation.
More like a giant, complex structure of mathematical relationships. But you're on the right track.
Okay, that's a pretty wild thought. But if our universe is just math, then who wrote the equations?
That's the beauty of it. Tegmark says that if a mathematical structure can exist, then it does exist physically somewhere in this level-feeding multiverse.
So you're saying there's no need for some kind of cosmic mathematician creating everything, it's just math doing its thing.
Precisely. Every mathematically possible universe simply exists. He calls it mathematical democracy.
Mathematical democracy. I'll have to add that to my list of cool science phrases.
Yeah.
So our universe, with its specific laws of physics, its fundamental constants, is just one of countless mathematically possible universes, all coexisting within this level V multiverse.
That's the gist, yeah. It's like every equation ever written and every equation that could ever be written represents an actual universe out there.
Okay, my head is officially spinning. We've gone from infinite versions of ourselves to infinite universes with different physical laws, and now to a reality where every mathematically conceivable universe exists. Phew. But how do we even begin to wrap our minds around that? I mean, is there any way to prove or disprove any of this?
That's the million-dollar question. It's something scientists are still wrestling with. One of the biggest challenges is this thing called the measure problem.
The measure problem. That doesn't sound good.
It's not as ominous as it sounds, but it's definitely a brain twister. It basically boils down to this. If there are infinite versions of you out there, how do you figure out the probability of any one of them experiencing a specific outcome?
I see what you mean. So instead of asking, what are the chances of something happening in the universe, we're asking, what are the chances of it happening to me, given that there might be an infinite number of me's out there?
You got it. And all those infinite yous, well, it gets really tricky to define what likely even means anymore.
I bet. It sounds like the measure problem is giving some physicists a real run for their money. But beyond the scientific hurdles, what about the philosophical implications of all this? I mean, if there are infinite versions of me making every possible choice, does that mean free will is just an illusion?
You know, those are the big questions, the existential ones that these multiverse theories really make us grapple with. If every choice you could make is being made by some version of you in some other universe, what does it even mean for you to make a choice?
Yeah, it really makes you think, doesn't it? Does Tegmark offer any answers to these philosophical questions?
The truth is, there are no easy answers when it comes to the philosophical implications of multiverses. Tegmark himself, he acknowledges that, but he suggests that even if we can never physically visit these other universes, just wrestling with these ideas, it can deepen our understanding of the nature of reality and our place in it.
You know, it's a lot to wrap your head around, but I think you're right. Even if these multiverse theories are just theories, they force us to think bigger, to consider possibilities that we might never have imagined before. It definitely makes you look at the night sky a little differently, doesn't it?
It really does. It makes you wonder what other incredible secrets are out there, just waiting to be discovered.
That's the beauty of science, isn't it? Always pushing the boundaries of what we think we know. Well, if this deep dive into the mind-blowing world of parallel universes has sparked your curiosity, we encourage you to explore further. We've got a link to Max Tegmark's paper, Parallel Universes, over on our website. Until next time, keep those minds open and keep asking the big questions.